Okay, so have you ever heard about a scientific discovery that's so huge it like makes your scientist cry?
Yeah.
That's kind of what we're dealing with today.
Wow.
We're diving deep into a Google quantum chip. They've nicknamed it Willow.
Okay.
And it seems to be like really pushing up against Einstein's theory of relativity
Seriously.
and maybe even hinting at, like a multiverse kind of situation.
Oh, wow.
So, yeah, we've got some excerpts describing this and all the background physics and stuff.
Okay, cool.
And like, we really want to understand what this could all mean.
Yeah, totally. Let's break it down.
Okay, so let's like go back in time for a second.
Right.
For like centuries, we had Newton's classical mechanics, like
Right.
his laws of motion, gravity,
Yeah.
all that stuff. It worked great for explaining the world, like how things move, why things fall.
Like the foundation of physics.
Exactly. But then the 20th century rolls around.
Oh.
And scientists start seeing things that Newton's laws just couldn't explain.
Like what kind of things?
Well, like the behavior of light, especially at really high speeds.
How interesting.
Yeah, it was like the universe was saying, hey, Newton, thanks for the laws, but there's more to this story.
Uh-huh. I like that.
So then Einstein comes in and basically rewrites the rules.
Einstein, the ultimate rule breaker.
Yeah. In 1905, he drops his special theory of relativity.
Okay.
And it's based on two, like, mind-blowing ideas.
All right. I'm ready.
First, the laws of physics are the same for everyone moving at a constant speed.
Okay, that makes sense.
And second, the speed of light in a vacuum is always the same, no matter how fast you're moving or where the light's coming from.
So the speed of light is like the ultimate speed limit.
Yeah, exactly. And from those two ideas, Einstein figured out some crazy stuff.
Like what?
Like time dilation, time can actually pass at different rates for different people.
Oh, wait, really?
Yeah, and length contraction things actually get shorter when they're moving super fast.
That's so weird.
I know, right? And it turns out space and time aren't separate. They're like woven together.
Space-time.
Exactly, space-time. It's so cool. But Einstein wasn't done yet. 10 years later, he drops another bomb. The general theory of relativity.
Okay, what did he come up with this time?
He said that gravity isn't a force like Newton thought.
So what is it then?
It's actually a curvature of space-time caused by mass and energy.
What, so like a bowling ball on a trampoline?
Yeah, exactly. Like that the bowling ball makes a dip in the trampoline, and that's how gravity works.
Wow, that's amazing.
I know, right? And this new theory explained things that Newton's gravity couldn't.
What kind of things?
Like the weird way Mercury's orbit works.
Oh, interesting.
Yeah, and it predicted things like gravitational lensing, where light bends around massive objects.
And they actually observed that.
They did, and it's like another confirmation of Einstein's genius.
So Einstein's rocking the universe with his theories of relativity.
Totally. But meanwhile, another revolution is happening in the world of the world of quantum mechanics.
Quantum mechanics, the land of the bizarre.
Yeah, it's all about atoms and subatomic particles, and it's totally different from relativity.
How's
Instead of the predictable laws of relativity, quantum mechanics is all about probability.
probability? So like things are random.
Yeah, in a way, particles can be in multiple states at the same time. It's called superposition.
Superposition. So like a particle can be here and there at the same time.
Kind of, but when we try to measure it, it snaps into just one state.
So it's like the act of measuring forces it to choose.
Exactly. And this whole idea of randomness really bothered Einstein.
I can imagine.
He famously said, God does not play dice with the universe.
Yeah, he really wanted to find a way to combine relativity and quantum mechanics.
He did. He spent years trying to find a unified theory.
So like a theory of everything.
Yeah, but it's been a huge challenge for physicists ever since.
Two powerful theories describing different parts of the universe.
Exactly. And it's still a mystery how to fully reconcile them.
So how did quantum mechanics even get started?
Well, it started with Max Planck in 1900.
Okay.
He figured out that energy isn't continuous. It comes in little packets called quanta.
Quanta, so like energy is quantized.
Exactly. And then in that same crazy year of 1905, Einstein used Planck's idea to explain the photoelectric effect.
The photoelectric effect, what's that?
It's like when you shine light on a metal and it knocks electrons out. And Einstein showed that light acts like particles too, which he called photons.
Wow, so light is both a wave and a particle.
Yep, wave-particle duality.
So mind-blowing.
Yeah, and then a bunch of other brilliant minds jumped in, Borda-Bruley, Schrödinger, Heisenberg.
A real all-star team.
For sure, they came up with ideas like quantized electron orbits, the wave equation, the uncertainty principle.
It's like they were piecing together a whole new picture of reality.
They were, and one of the weirdest, most important concepts that came out of all this is quantum entanglement.
Okay, entanglement, tell me more.
So imagine two particles that are linked together.
Okay.
No matter how far apart they are, their properties are connected.
What? So, like, if you measure one, the other one instantly knows?
Yeah, it's like they're communicating faster than the speed of light.
That sounds impossible.
I know, it's wild. Einstein called it spooky action at a distance.
Spooky is a good word for it.
Yeah, and this spooky action led to the EPR paradox.
What's that stand for?
Einstein, Podolsky, Rosen.
Got it.
They basically said, if quantum mechanics is complete, it has to explain this instantaneous influence.
Right, because nothing can travel faster than light.
Exactly. They thought maybe there were hidden variables controlling things behind the scenes.
So like a deeper level of reality we couldn't see.
Yeah, but then John Bell came along and changed everything.
What did he do?
He came up with Bell's theorem and Bell's inequalities.
Okay.
These inequalities set a limit on how correlated and tangled particles could be if those hidden variables existed.
So if the inequalities held up, Einstein and EPR would be right.
Exactly. But experiments showed that quantum mechanics violated those inequalities.
What? So Einstein was wrong?
Well, it's more complicated than that.
Oh, okay.
It means either those hidden variables have to be non-local, meaning they can act instantly across any distance,
Wow.
or quantum mechanics itself is non-local.
So it's like the universe is more connected than we thought.
It really seems that way, and all this entanglement stuff isn't just theoretical.
So there are real-world applications?
Yeah, like quantum cryptography.
Random cryptography, what's that?
It's like super secure communication that's basically unbreakable.
Wow, that's incredible.
And then there's quantum computing, which is what this whole episode is about.
Right, let's dive into that.
Okay, so quantum computing uses the craziness of quantum mechanics to do calculations in a whole new way.
Okay.
Instead of bits, which are like 0 or 1.
Right, the basic unit of information.
Yeah, quantum computers use qubits.
Qubits.
And here's the thing, qubits can be in a superposition, meaning they can be both 0 and 1 at the same time.
Whoa, that's trippy.
It is, and then
Yeah.
you've got entanglement where multiple qubits are linked together.
So they can work together in a way.
Yeah, and this lets them do tons of calculations at the same time.
It's like parallel processing on steroids.
Totally, and the potential applications are mind-blowing.
Like what kind of applications?
Well, in cryptography, they could break the codes we use to keep our information safe.
That's a bit scary.
Yeah, it is. But they could also revolutionize things like logistics, finance, AI.
How so?
By finding the best solutions to really complex problems.
Like finding the most efficient route for deliveries or the best investments.
Exactly. And in simulations, they could let us model molecules and materials with incredible precision.
So they could design new drugs and materials.
Yeah, it's like opening up a whole new world of possibilities.
So who came up with this idea of quantum computing?
Well, the early theoretical work was done by people like Richard Feynman and David Deutsch in the 1980s.
What did they figure out?
Feynman realized that classical computers would have a really hard time simulating quantum systems.
That makes sense. They're totally different worlds.
Yeah, so he suggested using quantum systems to simulate themselves.
That's brilliant.
And Deutsch came up with the concept of a universal quantum computer.
Okay.
Then in the 90s, Peter Shor developed a quantum algorithm that could factor large numbers way faster than any classical algorithm.
And that's important for cryptography, right?
Exactly. It means quantum computers could potentially break the encryption we use today.
Wow, so it's a serious threat to security.
It is. And since then, scientists have been working hard to build these super delicate quantum systems.
It must be incredibly challenging.
Oh, it is. But Google's been a major player in this.
Right, they have their quantum AI lab.
Yeah, they started it in 2013, and in 2019, they announced they achieved quantum supremacy.
Quantum supremacy, that sounds impressive.
It is. They use their Sycamore processor to do a calculation in 200 seconds that would take a supercomputer 10,000 years.
So they blew classical computers out of the water.
They did. And that brings us to December 2024 and the unveiling of Google's Willow chip.
Willow the next generation.
Yep. It's got 105 qubits, way more than Sycamore.
Okay.
And even more importantly, it's designed to handle error correction and scalability better.
Those have been big hurdles for quantum computing, right?
So Willow is a huge step forward.
And this is where Neil deGrasse Tyson enters the story.
Yes, Neil deGrasse Tyson, the astrophysicist and science communicator.
Yeah, he's amazing at explaining complex stuff.
He's a big fan of quantum mechanics, and he's always been super excited about quantum computing.
So he must have been thrilled to see Willow in action.
He was, but what happened next was totally unexpected.
What do you mean?
So Tyson visits Google's Quantum AI campus in February 2025,
Okay.
and they run some tests on Willow, increasingly complex calculations.
Yep.
And at some point, Willow starts behaving in ways that classical physics can't explain.
Seriously.
Yeah, it's like it was accessing information from somewhere
Well,
else.
like from another dimension.
Maybe. And this directly challenges Einstein's principle of local realism.
Local realism, remind me what that is again.
It's the idea that an object's properties are determined by its immediate surroundings.
Right, and that no influence can travel faster than light.
Exactly. But Willow seemed to be doing something that violated those principles.
Wow, so what exactly did Willow do?
Well, it was able to maintain coherent quantum states across what appeared to be multiple configurations at the same time.
Multiple configurations, you mean like multiple universes?
Possibly. And the results suggested that it was processing information across those multiple frameworks.
So it's like Willow was tapping into parallel realities.
It really seems that way, and this is the part that gets me a bit old. Neil deGrasse Tyson reportedly started crying.
Wow, he's not one to get emotional easily.
I know, and he said Google's quantum chip just proved Einstein's theory wrong.
That's a huge statement.
It is, and later he said something even more profound.
What was that?
He said, "I'm devastated. I've dedicated my entire career to understanding the cosmos through the lens of Einstein's theories. What we witness today doesn't just challenge our understanding of quantum mechanics. It fundamentally alters our perspective on the very nature of reality." Einstein famously said, "God does not play dice with the universe." Well, it appears the universe is playing a far more complex game than even Einstein could have conceived.
That's incredibly deep.
I know, it really makes you think about the nature of reality.
So what does this mean for the scientific community?
Well, as you can imagine, it's sent shockwaves through the world of physics.
Yeah.
It's like all of those theories about the multiverse suddenly became a lot more real.
Right, for years it's been a purely theoretical concept.
Exactly, but now we might have experimental evidence.
Evidence of other universes.
It's still early, but that's what it looks like.
So are physicists freaking out?
Some are cautiously optimistic, some are skeptical.
That's understandable. It's a lot to process.
It really is, and it raises so many questions.
Like what?
If quantum computers can access information from other realities, what does that mean for our understanding of time-space causality?
Yeah, like our whole framework of reality is being challenged.
It is, and it opens up a whole new frontier of scientific exploration.
And what about the practical implications?
Oh man, the possibilities are endless.
Give me some examples.
Well, think about materials science. We could design completely new materials with properties we never thought possible.
Like by drawing on the knowledge from other universes?
Exactly. And in chemistry, we could discover new reactions, new ways to create things.
It's like a whole new toolbox for scientists.
It is, and it's all thanks to this weird and wonderful world of quantum mechanics.
So what's the takeaway from all this?
I think the biggest takeaway is that the universe is way stranger than we ever imagined.
Yeah, it's like reality is far more complex and interconnected than we thought.
And we're just beginning to scratch the surface.
Google's Willow chip has given us a glimpse into a realm we never knew existed.
And who knows what other secrets are out there waiting to be discovered.
It's a truly exciting time to be alive and witnessing this scientific revolution.
It is, and it makes you wonder what other incredible breakthroughs are just around the corner.
What do you think the future holds for quantum computing?
Honestly, I have no idea, but I can't wait to find out.
Me neither. It's a wild ride for sure.
So to all our listeners out there, keep your minds open and stay curious, because the universe is full of surprises.
And maybe even other universes.
Maybe even other universes.
That's a thought to ponder.
It is. And that's a wrap for this deep dive.
Until next time,
Stay curious.
stay curious.
Why?